Wednesdays we wear pink, and it's May 5th.
Mr. Coswell. That I don't count.
All right, you guys will be able to find probability of simple and compound events. So, theoretical probability. What's it mean for something to be theoretical?
Thetor.
Okay, what's a theory? What's a theory? Yeah, not thetor. What's a theory? God. All right, what's a theory, guys?
It's like
Okay, it's kind of like a guess. Okay, normally it's an educated guess, right? Yeah. Is it always true?
No.
Okay, it's normally something that needs to be proven true, right?
No.
Okay, now so you're saying theoretical, it's saying this is a theory. Yes.
Theory like Bigfoot exists?
Sure. So in this case, it's probability that is theoretical. So this is where we're saying should happen, but it won't always happen that way. So probability is the measure of how likely. Come on. How likely an event is to occur. The set of all possible outcomes is called the sample space. So any outcome that could happen for an event is the sample space. So like, let's say I roll a die. What are the possible outcomes I get from rolling one die? What are the possible outcomes I get from... I get 1 through 6, right? So that's the sample space. 1, 2, 3, 4, 5, 6.
that was 1.
Okay. Okay. For equally likely outcomes, is it equally likely that I get any side of this die?
Yes.
Yeah, for equally likely outcomes, a theoretical probability of an event, or P of E, probability of the event, E, probability of E, is the ratio of the number of favorable outcomes to the number of total outcomes possible. This will make a little more sense when we apply it right here in this first example. A simple event is a probability of one event. So let's say we have a jar that contains 32 red marbles and 28 blue marbles. And you're going to randomly select a marble. We want to know what's the probability that's a red one. So as I look at this jar of marbles, as I select one, that was a botch. Let me try that again. As I select one of these marbles, I'm going to stick my hand and I'm not going to look. When I'm have my hand in there, do I know which one's red and which one's blue?
No.
No, there's no way to tell them apart, okay? So as I pull one out, what's more likely, do you think? I pull out a red or a blue one?
The blue one. The red one.
Why do we say red?
That's
There's more of them, okay? Well, how many red marbles are there? 32. How many total marbles are there?
Add them together.
Add them together?
You don't know how much.
Oh, yeah. 60.
60. So there are 60 total marbles, and 32 of those are red. So the probability we get a red marble is 32 divided by 60. Now, does this reduce?
Yes.
Yeah.
What goes into both 32 and 60?
2.
2, okay. 16 over 30, something even more go into it? Another what?
2.
Another 2. 8 over 15. So, that means I have an 8 in 15 chance of getting a red marble. All right. So, if I pull out 15 marbles, how many of them should be red? 8. How many should be blue? If I pull out 15, how many should be red? 8. How many should be blue?
8. 15.
9.
7. The other marbles. If I pull 15 out and 8 of them are red, the other 7 have to be the other color. Okay? Now, is that always how it's going to work out?
No.
No, I could end up drawing 9 red. And that'd be 6 blue. Okay?
You know that
We'll have all of the marbles in there.
that you have to hold it down because you don't.
That's belly line.
Because you don't want to interrupt class.
2. A letter in the word restoration is randomly selected. What's the probability of selecting a vowel? So we first need to figure out how many what and how many what there are.
How many letters?
How many letters and how many
Vowels.
vowels? How many letters are there?
1, 2, 3, 4, 5, 6,
11.
7, 8, 9. Yeah.
11. How many of those are vowels?
5.
5. So 5 out of 11. So what's the probability of us selecting a vowel? 5 out of 11. Can we reduce it?
No.
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 Wait, so one.
So what would the probability of us getting a consonant be?
5 out of 11.
11.
A vowel would be 5 out of 11. What's the probability of a consonant? 6 out of 11. The other ones. So what's more likely, you get a consonant or a vowel? Consonant here, right?
I wish you could have explained this a long time ago.
Isn't it helpful?
Well, I did this like first year here, and we did this same exact problem, and it was not that easy.
Well, I'm happy it's easier now. All right, we're going to skip number 3.
Why?
I don't like it.
Okay.
Why 3?
All right. 2 dice are rolled.
Doesn't like it.
So I have 2 dice here. Okay, see these?
Yeah.
2 dice. There's 6 sides on each. They're both fair dice, aka there's nothing funny about it. They both have a 1, a 2, a 3, a 4, so on and so forth, all the way through 6. If they're both rolled, we want to know the probability that the sum, addition, of the 2 on the is at least 9. So they add up to be at least 9. So like let's say I get a 1 and a 6. Does that add to be more than 9? Or 9 or more? No. Or let's say I roll them and I get a 1 and a 5. Is that at least 9? No. Now we could sit here and try and roll them all day and figure it out eventually, but that would take a long time, wouldn't it?
Yeah.
So,
Yeah.
okay. So, the fundamental counting principle we learned a couple classes ago here, and what we had at the very beginning of the last worksheet says, hey, if I have how many options on this die? 6. How many options on this die? 6. If I multiply those together, how many options do I have total? If I multiply those together, how many options do I have total? 36. So I have 36 total options. So my sample space is 36. That's the number on the bottom of the fraction. So now what we have to figure out is what's going to be the number on the top of the fraction. How many of these 36 scenarios are going to have a sum of at least 9? Let's write this out. So let's say my first die is a 1. How many different options are there for my second die if my first die is a 1?
6.
It could be a 1. It could be a 2. It could be a 3. 4. There. 4. 5. That's it.
6.
There's 6 different options. So you have 1, 1, 1, 1, 1, 1. That's one too many. Whoops. So I could have a 1, a 2, a 3, a 4, a 5, and a 6. Are any of those at least 9? No.
No.
Okay. Now what if I roll a 2 on my first die? What can my second die be? 1, 2, 3, 4, 5, 6. Can you guys start to see why there might be 36 different options here?
Yes.
Because I'm only 2 numbers through. And how many do I have for each number? 6. I have 6 for each number, and I have to go through 4 more numbers, right? So if I have 6 for each number, and there's 6 numbers, 6 times 6, 36. Now, do any of these add up to be at least 9?
No.
No. Now, will any of my 3s add up to be at least 9?
Yes.
3 times 6.
3 plus 6.
3 plus
Okay.
Why?
Any of my other 3s, will those add up to at least 9? No, okay. What about my 4s? Will any of my 4s add up to be at least 9?
5.
5 and 6.
5 and 6. 4 plus 5 and 4 plus 6 both add up to be at least 9. Okay? What about my 5s? 4,
5, 6.
5, and 6. What about my 6s then? 3,
4,
4. Someone not Mrs. Haswell?
5,
Thank you.
6.
No offense, Mrs. Haswell.
No, I'm just trying to follow along with you two.
Okay. Alright.
I feel like I'm one of them in
So,
this section.
if you can't figure this out in your head, which is probably going to be pretty darn tough for us to figure in our head, it might be a good idea to write out to make sure we get the options. How many of these options are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So out of the 36 possibilities,
What's so funny? I don't get
okay,
it.
hey, out of the 36 possibilities, how many of them have a sum of at least 9? 10. So 10 of the 36.
I don't get it.
All right. Does that simplify?
Yeah.
Yeah, no.
No.
Yes.
Yes.
Well, it can in a way, but like not even.
2.
Like, if you were to do 10, it doesn't go into it.
Okay, so 10 doesn't go into 36, but does something go into both? 2. So 5 over 18. So,
Guys! What's so funny?
what did I even say? Nothing.
It's a song.
Okay. So, that means if I roll the dice 18 times, how many of those times should I get it to where the sum's at least 9? The answer is 5. So that means the other 13 times, should the sum be at least 9?
Yes.
The other 13 times, should the sum be at least 9? No. Now, will that always be the case? No. Have you guys played like Monopoly or something like that?
I have.
Okay, where you use 2 dice?
Are you literally?
Now, do you sometimes like notice that like one number ends up getting more than all the others somehow? Like you end up always getting like 8s or something like that?
Yeah.
Okay.
Can I like go on a walk or something?
Yeah, I think it's a good idea.
Okay, thanks.
Okay?
Nothing fun.
No. All right. Let's go ahead and go on to number 5. What is the probability of drawing a heart or a club from a standard deck of cards? Well, let's look at this deck of cards I have with me.
I have a quick question.
Yeah.
before we move on. Is that how you want us to figure out that there's 10 out of 36 is to write it
I
all
think that's
down?
probably the best way. Yeah, I think it's probably going to be the best way. You're what? About what?
All of it.
That doesn't help me. Like, were you confused on the first problem we did?
Everything.
Okay, so like, this first problem we did confused you.
Yeah.
Okay, with the marbles.
Okay, no. Wait.
Okay, this is why I'm trying to ask.
Like, how'd you get to 60? Like,
Yep.
That's the problem. I don't know.
Okay, so there are 32 marbles. How many marbles are in the jar?
You add them together.
32 plus 28.
Oh.
And there's red and blue marbles in there.
Oh, okay.
How did I get the 11? Well, how many letters are in restoration?
Okay. Yeah.
How did I get 36? Well, how many different options there are for when we roll a dice? Okay, so what's the probability of drawing a heart or club from a standard deck of cards? What are some facts we know about a deck of cards? Raise your hand and tell me some facts we know about a deck of cards. Tucker.
There's 32 cards. 30, no.
There's
52.
52 cards. There's 52
close.
cards total. So here, our sample space is going to be what then?
52?
52, because there's 52 cards, okay? Now, what else do we know about a deck of cards? Raise your hand and tell me something else we know about a deck of cards.
There's several of
There's 4 of each.
Okay, 4 what? 4 of each what?
4,
like numbers or letters.
Okay, 4 numbers or face cards, right? 4 10s, 4 jacks, 4 aces, 4 4s, 4 whatever. Okay, what else do we know?
It counts up. It starts from 1 to 10.
Okay.
Then it has
Okay, it goes from ace to 10, and ace is kind of the 1. And then you have jack, king, queen. So how many cards are there per suit?
14. 15.
So it goes ace, 2, 3, 4, 5, 6, 7, 8, 9, 10,
13.
jack, queen, king.
13.
13 cards per suit. Now how many suits are
I
there?
forgot there wasn't a lot.
4 suits. What are our suits?
Oh, spades. Okay.
Spades.
Puppy feet.
Yep, with the puppy feet. What are the puppy feet called?
Clubs.
Clubs.
Yeah.
Okay. What's this one called?
Hearts.
Hearts.
Diamonds.
And then the last one is diamonds, isn't it?
Yes.
Okay. So those are our 4 suits. Okay. And then half the cards are what color?
Black.
And the other half are red, right? So half black, half red. Okay. So what's the probability of drawing a heart or a club from a standard deck card? So how many of these cards are going to be a heart or a club?
8.
Half. So 20, not 25.
21.
20,
26.
26. There's going to be half of them, right? 2 of the suits. So what would that reduce to then, Hannah? Well, you just told me a moment ago, actually.
25. That's what I said.
Before that.
Oh, what? 50.
26 divided by 52. Does 26 go into both numbers?
Well, yes, it does by 4.
Does 26 go into 26? It becomes 1/2. You said it was half.
Oh, yeah, I just said that.
So what's the probability of drawing a heart or a club? Half, 50%. So if I draw a card, there's a 50% shot I'll get a heart or a club, and there's a 50% shot I won't. hey, I got a club. Okay? So the odds are that my next one won't be, right? Oh, I got another club. Got another club. Apparently not. Heart. Man, that's rigged right now. Diamond. Spade. Club. Diamond. Heart. Okay, anyway. So if I go through this whole deck, eventually, it'll kind of even the odds out. It'll kind of even the odds out as we continue going through it.
Alright, go back to trick right now.
I don't know what tricks. All right, I'm not a magician. I'm a comedian. All right,
I don't think you're
You can be both.
let's skip 6.
You're definitely.
Why are you skipping so much?
Yes.
Because he doesn't like them.
Best to write all the information that we know down so we start narrowing the things.
If it's helpful for you to write some information down, then do that. If it's helpful for you to write down, hey, there's 52 cards, there's 4 suits, 13 cards per suit, stuff like that. If it's helpful for you, write it down. All right.
I just
Com-
don't know without doing that how you would use start.
On some of them, yeah, for sure. Complement of an event. The complement of an event is a probability of the event not happening. Take a breath. It's a probability of the event not happening. Because either the event happens or it doesn't happen. Those are your two choices, right?
Yeah.
Like when I flip a coin, either it's heads or it's
Tail.
tails. Those are the only options. Okay? It's going to be one or the other. So what we say is, what are the odds of us getting heads?
50-50.
Yeah, it's 1/2 of it, right? What are the odds of us getting tails?
6-6.
1/2. So if I flip a coin, what are the odds that... let me try and word this the way I want you to answer it. What are the odds that I get at least one of these two results?
Half. It's 50-50.
Well, what are the odds that it shows up heads or tails? Like, not saying it shows up heads, or what are the odds it shows up tails? What are the odds that at the end of the day, it's at least one of these two? 100%. Every time I flip it, I'm going to get at least one of them. Does that make sense? Every time I flip it, I'm going to get at least one of these options. Mason, put it away. Thank you.
Oh, I think like, as a joke, I was like, how the hell you?
No. Okay. 100%. And now what happens if you add 1/2 and 1/2? What do you get? 1. So in probability, 1 is saying it's 100% going to happen. 1 is our 100% in probability, okay?
Okay.
What's up?
Can I sing for school?
I don't know my schedule right now, dude. I'm on my computer. We're in the middle of the lesson. Okay.
Because I guess.
Let's continue on. Now what time is it? The sum of all probabilities in the sample space is 1, like we just talked about. If we add up all the possibilities, we're going to get 1. 1/2 plus 1/2 is 1. The probability of an event not happening, P of not E, probability of not, that little squiggly line up there, means not.
Awesome.
You take 1 and you subtract the probability of it happening. We're not even on that page anymore. Or actually, we were on the page, sorry. I was wrong. We have written down the last few blanks.
Is it rain today?
I don't know.
Yes, it is.
Okay, guys, I'm starting to get confused a little bit, so can we?
Yeah.
Back just a minute. Thank you.
All right. Yeah. Not right now. You already had a big break already this period. I know. All right. So, 2 dice are rolled. This is the problem we had earlier, right? We said, what was the probability that the sum was at least 9? We said 5 out of 18. So what's the probability that it's not at least 9, that it's less than 9? Well, you take 1 and subtract your 5 over 18. And what do you have to do when you add and subtract fractions? What do you do when you add and subtract fractions? Okay, you got to get 1 underneath. And what do you need? You need common denominator, okay?
No, not
That's
those
good. You need common denominators. What's our common denominator going to be? This isn't going to be that bad, guys. Trust me. 18. Now, we're going to turn a 1 into an 18 by multiplying. That's going to be easy. We're just going to multiply by 18. And you do the top and the bottom. So what's 18 times 1? 18. And what's 18 times 1? 18. It's just 18 over 18. Because is anything divided by itself 1?
Yeah.
Yeah. So we're doing 18 over 18 minus 5 over 18. What's 18 minus 5?
13.
13. So what are the odds that the sum is less than 9? 13 out of 18.
18 minus
So-
18. 0.
The bottoms, you don't subtract them. That'd be like saying you have a whole pizza, 2 halves, and you take away 1 half, oh, you have 0 pizza. That's not, you have 1 half still, right? So, we just basically can change this, the 1, into an 18 over 18. Okay? And you subtract it. So there's 13 out of 18 scenarios where it's less than 9, because 5 and this 13 have to add up to all of our options. Because is there any way you roll 2 dice and it's not in one of those 2 categories? No, it's either going to be at least 9 or less than 9. There's no in between there, okay? So the probability that it will snow tomorrow is 7 over 20. What's the probability that it won't snow then? The probability that it'll snow is 7 over 20. How do we figure out how likely it is not to? Subtract from 1. So you take 1 minus 7 over 20. Now we need common denominators, right? And it's going to be 20. So we're just going to take the top and the bottom and make them both 20 essentially. Because is that still 1? Is 20 divided by 21? Yeah. So we're still subtracting from 1. But did we just make our life easy with common denominators? Yeah, we aren't even having to try and figure out, oh, what's the common denominator going to be? What am I going to have to multiply? Don't even have to worry about it. So what's 20 minus 7, Lainey?
Something like that.
13.
Oh, you don't need a calculator for that.
Isn't it 13?
20 minus what?
7.
Yeah.
13 over 20. So the odds of it not snowing would be 13 over 20. Let's go.
Sorry.
Thank you. Questions on that? Okay, on 8.
This one's easy, actually.
A month of the year is randomly selected. What's the probability of getting a month that does not begin with the letter A? Well, how many months begin with the letter A?
April.
January, February, March.
April,
2.
Only
May,
one.
June, July,
Two.
August,
That's-
August.
Oh, art.
September,
That's my
October, November,
birth-
December.
So how many started with A?
2.
2. So out of 2 of the 12 started with A, 2 out of the 12 started with A. So what's the probability of not starting with A? Well, what do? You take 1 and subtract it from that. Or you take 1 and subtract the 2 over 12. Does that make sense how we get that?
Yep, 12.
Yeah.
And so this is really 12 over 12.
So 10 over 12.
Yeah, and does that simplify even?
Yeah. 6 and 5.
Yeah. So what are the odds that you get a month that does not begin with the letter A?
5, 6.
5, 6. Much more likely, right, than it starts with A.
Yes, sir. This one's easy.
Good.
No, it's not. Yesterday was easier.
Good.
Okay. Let's skip number 9. Let's go to number 10. All right. 2 dice are rolled. We talked about this earlier, right? How many scenarios are there for 2 dice being rolled?
6.
6 times
32.
6 of 36.
36.
There you go. So what's the probability of getting doubles? So we have to figure out the probability of not getting doubles. So to do that, we have to figure out the probability of getting doubles and subtract it from 1. So when we went through and wrote some out earlier, how many of these were doubles in the first 6? 1. How many were doubles in the second 6?
2.
Another 1. Okay. How many doubles are there going to end up being?
4. 6.
6 total, right? You got double 1s, double 2s, double 3s, double 4, double 5, double 6. So 6 out of these 36 are doubles. So to figure out the non-doubles, you take 1 minus the doubles. Because either it's a double or it's not. There's no in between.
So 36 over 36.
So yep, you make it 36 over 36. And what's 36 minus 6? 30 over 36. And did that simplify?
Yes.
To what?
15 and
1 and 6.
no.
No, 30 and wait, 15 can't simplify into 36.
It could go to 15 and 18. But could we simplify it even more?
Yeah.
What goes into 30 and 36 that's big? Bigger than 2.
13.
No.
3,
3. No, something even bigger than 3.
12, 6.
6. How many times is 6 going to 30?
6.
5. How many times is it going to 36? 5 out of 6. So what's the probability of not getting doubles? 5 out of 6. So if you roll the dice 6 times, how often should you see doubles?
Are we done?
5 out of 6.
5 times. 6 times.
Wait, let me say that again. I tricked you. If I roll the dice 6 times, how many times should I see doubles?
5.
5, 6, 1.
1. Because how many times should I not get doubles? 5. I should not get doubles 5 of the times, and I should get doubles 6 times, or 1 time, right?
Roll the dice 6 times.
1 and 5. 2 and 3. 5 and 3. 1 and 3. That's 4. 6 and 5. Ooh, last one. 4 and 4. It worked out, okay? Now, will it always work out exactly like that? No. But that's what the odds say is it's most likely to happen that way. It's most likely to happen that you'll get 5 out of 6 that are not doubles and 1 out of 6 that are.
How is that even possible?
Now, it won't always happen that way, okay?
What if you get doubles like the whole entire time you roll?
Because here's the thing. Here's the thing. Okay? Here's the thing here. If I roll the dice once, does that change or have any impact on my next roll?
Well, no.
No, it really doesn't, right? The dice don't remember what they were on last. Okay? That's not a thing, okay?
Yeah.
So, is it possible to have doubles 3 or 4 times in a row?
Yes.
Yeah, is it very likely though?
No.
No, okay? And just because you have doubles 3 times in a row, does that mean you're not going to have them for another like 30? No, you could have them pretty regularly after that too. Okay? So, it's just saying every time you roll them, there's a 5 out of 6 chance you don't get doubles, and there's a 1 out of 6 chance you do. The next time you roll them, it's the same odds. 5 out of 6 chance you don't, 1 out of 6 chance you do. The third time you roll them, same odds. It's just if we do it enough, experimentally, that's what should happen. Yeah.
It's a different case with computers, though. Computers do remember the last roll they had.
Oh my God.
Depending on the programming. It could be, it could not be.
Mr. Crossell,
What's up?
it's supposed to rain.
Okay.
At 3, 5, and 6.
Continuing on. Compound events. Compound are different than simple.
Well,
Compound is 2 or more simple events. No!
That's fine.
This one's hard.
Okay, so we have independent and dependent events. I don't think it's not that hard, okay? Compound events are saying that, hey, more than one event's happening. You do this and this. Now, independent means that they don't depend on each other. So what do we think dependent's going to be? They depend on each other. Man, you guys are bright. Okay? So the probability of A and B happening, this event and this happening, is the probability of the first event, A, times the probability of the second event, B. Whereas the probability of a dependent event is the probability of the event A happening times the probability of event B happening, but after A occurred. We'll talk about what that means in a moment. But first, we're going to go to E, independent.
Holy crap, you wrote that fast.
Dude, I can't concentrate.
Okay.
Look down one time and you're already halfway done.
Zoom, zoom, zoom.
Can we go on a walk?
Maybe.
No.
Just stop doing what we're doing.
Okay. So a die is rolled 3 times. Once again, we just talked about how does the previous die's roll impact the next die roll? No, it doesn't. So this is an independent event. It doesn't depend on the previous event. What's the probability of getting 1s on each roll? So my first roll, what's my odds of getting a 1? My first roll, if I roll 1 die, what's my odds of getting a 1? 1 out of 6. There's 6 options, and one of them is a 1. So 1 out of 6. Roll it again. What's my odds of my second one? 1 out of 6. It didn't change. Okay. What's the odds of my next one? 1 out of 6. Okay.
Yeah,
Ooh, not quite. We multiply them. We multiply them here, okay? Because it's less likely to get it multiple times in a row. Now, if we said, what's the odds of it getting once in these 3 times, that'd be different.
Why is it all
That'd be
about dice?
because it's just something that you see commonly. Are you guys pretty familiar with dice?
Yeah.
That's why. It's something you see more commonly.
I was just asking.
Yeah. No, I mean that's a great question. I'm just saying that's why, because you guys know what I'm talking about if you use dice. Yeah.
No, when you play Dungeons and Dragons, which is fun,
Mm-hmm.
which is what I normally play with dice.
Yep.
There's
All sorts of them.
24 size dice.
Yep. D20s, D24s,
Yeah.
D30s, D100s, D8s, D4s, D3s.
Need a bed.
Okay. Yes.
Can I go to the restroom?
Yes. Good luck.
Thank you.
So for here we multiply. We multiply on the top. What's 1 times 1 times 1?
1.
1. What's 6 times 6 times 6?
36 times 6, got it.
Yep. 216.
216. Good job.
So what are the odds that I get 3 ones in a row?
216.
1 out of 216. So how many rolls would it take me to get to just about guarantee it? 216. I could sit here 216 times, and eventually I should get one of them to be 3 ones. Now, will that always be the case?
No.
I might not get any. I might get more than one. Who knows? But that's what the odds say, is I should get it 1 out of every 216 times.
36 times 6. So 36 times 6.
Yep.
I think 24, what was it called?
I'm going to pause that then. A coin is tossed, then a day of the week is selected. Do those impact each other at all? Does how the coin toss depend on what day of the week it is? Not even close. Tucker's just like, no. Okay. So what is the probability of getting tails than a day with the letters starting with T? So what's the probability of getting tails?
1 out of 1.
1 out of 2. What's the probability that a day of the week starts with T?
1 out of 2.
2 out of...
2 out of...
How many days of the week start with T?
2 out of
Tuesday, Thursday. 2 out of how many days of the week are there? 7. So you multiply 1 over 2 and 2 over 7 because it's an and event. You're saying, hey, what's the probability of this and this happening? Now, hey, let's make our life easier. Can we cross reduce here?
Yeah.
Is something going to 2 and 2?
4.
2 goes into both, and they both become 1. So when we multiply straight across, what is 1 times 1?
1.
And what's 1 times 7?
7.
So what are the odds of getting tails and something that starts with the letter T? 1 out of 7. Okay. We're just going to do 3 more problems. Okay? Cool beans? 3 more problems. That's not bad. That's not bad.
Boo.
What?
Wait,
Okay.
what?
What's 3 more problems we're going to do?
Okay, 4. Cool.
Okay.
No.
All right. A bag contains 8 red crayons, 14 purple crayons, 6 yellow crayons, and 4 green crayons. If you say it any differently, you're wrong. A crayon is selected, replaced. No, here's how it's spelled. Here's how crayon would be spelled. Like cranberry. Okay? It's not spelled like that. You're missing 2 letters. Okay? Now, after I grab out a crayon, what does it say I do with it? It says it is replaced. So I put it back in the bag and I go and grab it. I go grab another one. So does the number of crayons ever change in the bag? No. So what's the probability that my first crayon is purple? Well, how many purple ones are there?
1 out of 4.
There's 14 purple ones. How many total crayons are in the bag, though? 32. What was that? Okay. So there's 14 purple crayons in the bag and 32 total crayons. So the odds that I get a purple one are 14 over 32. Now, let's say I grab the purple one, I put it back. What are the odds my next one's yellow? 6 out of 32, and I multiply those together. Now, once again, I'm going to recommend cross-reducing before we go any further. And you can reduce inside of the own fraction as well. 14 and 32. Is anything going to both 14 and 32? 2. It becomes 7 over 16. 6 and 32. Does anything go into 6 and 32? 2. And it becomes 3 over 16. Now there's nothing more you can reduce. Multiply straight across with 7 times 3. Anyone. And 16 times 16, 256. So the odds that you get a purple and then a yellow, 91 over 256.
This is hard.
It might be easier if you have your mask out.
What's the P
Jeez, Mason.
Probability. So it's saying, hey, probability of this event. So here we see P parentheses, guys. Great question. P parentheses is telling probability of this. Probability of this.
Got it.
Thank you, Mr.
Yep.
Thompson.
We're going to skip those other three.
Sweet.
Dependent events. These are ones that are going to depend on each other. Using the same example from above with all these crayons, but assume once a crayon selected, what happens? It is
Not replaced.
not replaced. Once I take one out, am I putting it back in? No. Is that going to change how many crayons are left?
Yeah.
Yes. So find each probability. Find the probability that we get a yellow crayon. So fresh bag, 32 crayons in there. What's the probability I get a yellow?
6 out of 32.
6 out of 32. Now, I take one out. How many crayons are in there now? 31. So what are the odds that out of the 31, I get a red?
8 out of 30.
Yeah, there's 8 red crayons still, because I took a yellow.
Yeah.
I took a yellow. So there's 8 red ones in there still. So I multiply these together. See how that changes based upon whether or not we replaced? Okay, so we can simplify though. 6 and 32, we simplified that to what over what earlier?
21.
3 over...
I thought cross multiplication or whatever went like this.
So you can cross simplify into 6 and 31, 8 and 32. You can also simplify it within a fraction. If I cover that up, could we simplify this fraction?
Yeah.
Yeah. What goes into 30? What's 32 divided by 2? 16. Now, can 8 and 16 cross simplify diagonally?
Yeah.
Yeah. Well, not 1 and 6, but 1 and, nope, 2.
What?
8 goes into 16 twice. So on the top here, 3 times 1.
3.
On the bottom, 2 times 31.
I was talking about 32.
62. Oh, okay, gotcha. But we have to go off the number we already reduced it to. Does that make sense? So we end up getting 3 out of 62 is our odds of this happening. Question on that?
Nope.
Okay. So what's the probability of us getting 2 reds? So what's the probability of us getting 1 red to start? 8 out of...
30.
Okay, this is a new problem, so there's still 32 crayons.
8 out of 32.
So now, I take a red crayon left. What's my probability of getting the next red crayon?
7 out of 31.
7 out of 31. Why is it 7?
Because you took out 1 red.
Because I took a red one out.
How do you know we took the red one out? It could have been a blue.
Great question, because it says the probability of 2 reds in a row. So we have to assume... Okay, hey, Lainey, great question. Let's go up to a little bit ago. Right here, okay? Can you look up here? For dependent, probability of A, so that'd be the red crayon, 8 over 32. Probability of B, after A occurred. So for the probability of the second one, we are saying we already did the A. A already happened. So we're saying, oops, went too far. We said we already took the red one out, so we have 7 left. Because if you took anything other than a red one out, we might as well stop bothering because you're not going to get 2 reds. If you grabbed a blue, there's a 0% chance your next one's red anyway.
What's this going to do for me in the future?
So probability and statistics can actually help just with normal games, normal life. Let's say you're going to go to a casino and gamble sometime.
Yeah.
Probably could actually help you in that, do better at that.
Okay.
Talk to Mr. Titus about it sometime.
Okay, I will.
That's not accurate.
20.
Okay.
18.
So, let's reduce here.
14.
8 and 32. What goes into 8 and 32? 8. And 8 goes into 8 once, and it goes into 32 4 times. Can 7 and 31 reduce? No. And 1 and 31 can't. 4 and 7 can't. So, what's 1 times 7? 7. 4 times 31?
Bro, this math.
124. So probably getting 2 reds in a row is 7 over 124. All right, I'm going to say true to my word that we did the 3 problems, even though Lainey asked for 4. So once again, guys, we're doing the evens on those first 2 pages.
Are you going to raise and do this or something?
Making her cry? Yeah.
I doubt it.
No, give me a raise.